So here we have the fifth root. So first take the number, and that's the only thing to work with, and break it down. And 32 is 8 times 4. 8 is 2 times 2 times 2, and 4 is 2 times 2. So that is equal to 2 to the 5th power. So when you break it down, I would like to see a 5th power, or a power that is a multiple of 5. So we have 2 to the 5th. So we're taking the 5th root, not the square root. X to the 10, y to the 5. And the way this works is 2 to the 5th, x to the 10, y to the 5th. Each of these is divided by 5. Since it's the 5th root, you divide by 5, just the exponents, remember that. So this is equal to 2 to the 1, this is equal to 1. 5 goes 2 times into 10, so that is equal to x to the 2 and y to the 1. And the reason why we divide by 5 is because you have 2 to the 5th, x to the 10, y to the 5th, and the 5th root is the same as a power of 1/5, and each of these is multiplied with a 1/5. Now let's look at the next problem. It's the 4th root, so let's look at 81. 3 times 3 is 9. 9 times 9 is 81. So this is a 9 and this is a 9. So when you break it down completely, you get 3 to the 4th. And that's convenient because we are taking the 4th root of. So that is, the only thing to do is make sure you break down the number, and the power is a multiple of 4. So it's 4 times 1, so that's good. A to the 24, B to the 8th. So the way this works is write down all those. This, remember, is the 4th root, not the square root. A to the 4th, A to the 24, and then B to the 8. Since it's the 4th root, each of these exponents, only the exponents, get divided by 4. So this is equal to 3 to the 4 over 4 is 1. A to the 6, 6 times 4 is 24. B, 4 times 2 is 8. So it is A to the 6th, B squared. Next, this is the 6th power. Now 32 times 2 is 64. So I multiply with another 2. So that becomes 2 to the 6th. And that's convenient because we are taking the 6th root off. So this is 2 to the 6th, x to the 6th, y to the 18. So this is equal to 2, this is, remember, the 6th root, 2 to the 6th, x to the 6th, y to the 18th. Since we are taking the 6th root, we divide each of the exponents by 6. So 6 over 6 is a 1, 6 over 6 is a 1, 6 times 3 is 18, and now we know what our answer is. It's 2 to the 1, x to the 1, y cubed. First we'll look at just very rough sketches of two basic functions, the square root function and the cube root function. Now, when I say what's the domain of the square root function, domain is all x's. So you look at the x-axis, all the x's for which the function is defined. So I pick any x here, the function is defined because I can find the value of f of x on the y-axis. I pick anything here, that's the value of the function on the y-axis. and I can keep going to the right forever, which means starting from 0 up to infinity, which means you can keep going on forever, and I'm going to include a 0, I know that the function is defined for sure. But when I look at the negative side of the x-axis, notice that if I pick a negative 1.25, the function doesn't even exist in that area. The function is undefined for anything negative. And it makes sense because you know that the square root, positive square root of a negative number is undefined. And that's why the graph doesn't exist on the negative side of the x-axis. So what is the domain of this function? It is of the square root function. It is 0 to infinity. Now similarly, if I have the fourth root, square root is the second root, fourth root, sixth root, eighth root, 10th root, and notice the pattern 4, 6, 8, 10, 2, 4, 6, 8, 10. If any of these radical signs, then the domain is 0 to positive infinity. I cannot plug in anything that is negative into these specific functions. Notice that these roots are even roots. No negative sign inside even roots. Now I want you to look at the second function, y equals the cube root of, notice that cube root is a 3. A cube root is the third root. It's an odd number. Graphs of other functions, the the fifth roots, the seventh roots, and so on. So the fifth root of x, the seventh root of x, they're all defined for negative numbers as well. Notice if I pick a negative number, the function does exist and I can evaluate the value of the function. I can evaluate the function. I can find the value of the function on the positive side as well. So what is the domain of this sort of function? Any number can be plugged in and the function is perfectly defined. And when is it defined? Cube root of, fifth root of, seventh root of, ninth root of, any of these odd roots. It is negative infinity to positive infinity. Now let's look at some specific functions. This is the square root function. So it does have a restriction. A square root of a negative number is undefined. So the inside cannot be negative. It has to be greater than or equal to 0. Notice the symbol. It's an inequality. It has to be greater than or equal to 0, which means it has to be 0 or greater, or a positive number. The inside. And now solve this. Let's see when the inside is greater than or equal to 0. I subtract 3 on both sides and I get x is greater than or equal to negative 3. So what is the domain of this function? What am I allowed to plug into this function to get a legitimate or a valid answer? I can plug in any number equal to negative 3 or greater than negative 3. So if I plug in, let's see, if I plug in a negative 3, I get a negative 3 plus 3, which is 0. Perfectly fine. If I plug in anything greater than negative 3, so remember that this is negative 3, anything greater than negative 3, let's say a negative 2. Square root of negative 2 plus 3 is 1. Perfectly well defined. I plug in a 0. I get a square root of 0 plus 3, perfectly well defined. But what if I plug in a number that is less than negative 3, let's say a negative 4. What happens when I plug in a negative 4 into the function? It becomes negative 4 plus 3, which is square root of negative 1. What's wrong with that? It's undefined. A negative inside the radical sign is undefined. Anything less than -3, let's say a -5.25, anything 5.25. So that's a -5.25 plus a 3, clearly a negative inside the radical sign, undefined. So what works? What are the values of x I'm allowed to plug in? Anything greater than or equal to -3. So if I'm going to graph this on the number line, it's going to look like this. -3 is here. Anything to the right of -3 is fine. So it's all real numbers starting from -3 and greater, which means you have to go to the right to positive infinity. That's the domain of the function. Now, again, it's a radical sign, square root of, even root. So then the inside absolutely has to be greater than or equal to 0. It cannot be less than 0. So the inside, whatever it is, set it greater than or equal to 0. So solve this inequality to get the values of x you're allowed to plug in. So you have 2x is greater than or equal to 10. X, when I divide both sides by 2, I get x greater than or equal to 5. What does this mean? I'm allowed to plug into this function any number greater than or equal to 5. So on the number line, if this is a 5, I can plug in a 5 and anything to the right of it. So that is 5 to infinity. So we have x greater than or equal to 5. So the interval 5 onwards, which means greater than or equal to 5, works. So that is the domain of the function. Now let's look at the next function. Now remember, you know the drill. If you see an even root, 4th root, 6th root, 8th root, here it's a square root, whatever is inside, you need to be making sure that it's greater than or equal to 0. What happens when it's less than 0? The square root of a negative number, a number less than 0, is undefined. So you have 8 minus x has to be greater than or equal to 0. I'm going to add x on both sides because I don't want a negative in front of the x term. So I'd rather add x on both sides, and I'd get x 8 greater than or equal to x because these two cancel each other out. I read it backwards. It says x less than or equal to 8. So I'm allowed to plug in any number less than or equal to 8. If this is an 8, I can plug in an 8 because 8 minus 8 gives me a 0, which is perfectly fine. And I'm allowed to plug in anything less than 8. Let's say I plug in a 7. So it's 8 minus 7, which is perfectly fine. It's a positive number. 8 minus 6. Anything smaller is good. I get a positive number. Anything left of 8. So it is negative infinity to 8. Anything to the left of 8, less than 8 or equal to 8 is fine. That's why we include 8 and anything less than 8.